multiply and divide numbers in scientific notation with positive exponents. It's always fun to play with positive exponents. Okay, so scientific notation, just real quick to recall, scientific notation is a number that has to be between 1 and 10, and then we multiply by 10 to some power. Okay, so we're multiplying. These are either really big numbers or really small numbers, but that's the idea of scientific notation. The key is that we're multiplying these numbers together. So when I say, let's multiply 2.1 times 10 to the 4th times 4.3 times 10 to the 6th, you'll notice I said times 3 times. So these are basically 4 numbers being multiplied together, and that's kind of the key there. So we can multiply these in any order. So we're going to take our non-base 10 numbers. So 2.1 times 4.3, and then we're going to group our base 10. So times 10 to the 4th times 10 to the 6th. So when I multiply 2.1 times 4.3, I get 9.03. And then multiply with the same base, I add the exponents. So times 10 to the 10th. Now, one thing to always check when you're playing with scientific notation, you always want to check that your final answer, that your first number is between 1 and 10. In this case, 9.03 is indeed between 1 and 10. So that's my answer, 9.03 times 10 to the 10th. And now let's divide. So 8.4 times 10 to the 7th divided by 2.1 times 10 to the 3rd. Again, let's start with our non-base 10 numbers. So if I take 8.4 divided by 2.1, that comes out nicely to 4. I'm not mad about things that come out nicely. Then I come over and say, okay, if I have same base, I subtract the exponents. So 7 minus 3 gives me 10 to the 4th. So my final answer is 4 times 10 to the 4th. Now, if they ask you to change that to standard form, you would simply move your decimal, you know, the usual. Let's do 2 more that are slightly different. 5.3 times 10 to the 3rd times 6.7 times 10 to the 4th. Again, let's do our non-base 10 numbers first. When I multiply those together, I get 35.51, and hopefully alarm bells start going off in your head because 35 is definitely bigger than 10. Okay, so now I have my same base, so I add my exponents. 3 plus 4 is 10 to the 7th. This is not your final answer because 35 is greater than 10. So the idea is, okay, so let's take this number and let's just change that to scientific notation. So I need to move my decimal one place. So 3.551 times 10 to the 1st, right? That's just 35.51. Then you can say, well, I still have times 10 to the 7th. Back up. I know this is a positive 1, the 3.551 times 10 to the 1st, because 35 is bigger than 10, right? Bigger than 10 means positive exponent. Okay, so now I can take these, 10 to the 1st times 10 to the 7th, and my final answer is 3.551 times 10 to the 8th. Great, great. One more. Dividing 1.2 times 10 to the 9th divided by 7.5 times 10 to the 3rd. So I divide 1.2 divided by 7.5, and that gives me a 0.16. Again, alarm bells should be going off because that is less than 1. So for B scientific notation, that has to be between 1 and 10. Now when I do my base 10 numbers, I subtract my exponents, and I get times 10 to the 6th. Not your final answer. We, again, need to change this to be between 1 and 10. And I know that 0.16 is smaller than 1, so this is going to have a negative exponent. So when I move it one place, 1.6 times 10 to the negative 1st. Again, small number, negative exponent. Times 10 to the 6th. Let's just bring that one down. So when I combine my base 10s, I end up with 1.6 times 10 to the 5th.